Okay, here's another. Hello, this is a video that data analysis, and this works through video. We're going to issues regarding data that has 100 data analysis and 1,000 to the extent it there uses hydro data in a also addresses some hour by hour format month by month. And what I want to do is just get the average by month for each year, so we can graph almost 158,000 is typically because are they peak shaving, are they hour by hour data in generation, how much water is released. So in order to do that, we're going to use the average if level from the, and then we're going to arrange the average if for the 12 months. The function is, here are some of the things we're going to do. I hope I'm going to show you in this video. We'll first compute, number one is the average if generation from, and number two is just the EOMONTH month. Okay, so step one is to put EOMONTH and hydro analysis. Just take this, then we'll each separate date. If you just, excuse me, get the end of the month, we need that in order to get it started. Then what we'll do is we'll take the first end of the month, take and then use the EOMONTH again. Okay, if we increment it by one. Now, in the last video, in the first video, I illustrated something called a data quarter. Let's use the EOMONTH and just shift control down. Take the last date and add one. So look at the shift control 3 to get the date format. Then we can take these dates, copy them, release data, have our end of the month going back, and it doesn't have a scale on it. We'll put 498, 99, 2000. Now, so once we get this, so why don't we summarize this and get all the way to the end? Whoops, by year 2014. Let's take an average. Okay, and then now to make this work, let's just put in, let's look at January, and how about the average? February, we can get them both for release and generation data. Then we'll also why don't we look at the volatility of September? I don't have that months on an annual basis and perhaps on a monthly basis. Okay, so much. Now to the final, we can just use the average if to get the average. Let's look at hourly. Again, this is for the hydro panel. Then selected. That's not the right one. Yes, it is. You take the end of the month, and then you go to the EOMONTH date year. Now the way to do all of this, click on that to use a few copy functions. First, our favorite, copy it all the way across. We're going to put functions used here. And of course, I forgot to lock in a couple of things. We always would have to lock in index and match these ones. And then let's also, and we'd also have to lock extremely helpful would be the average. Those two functions, we can do so much of this analysis. Now the first thing is this is a U.S. hydro facility. It's called the Glen Canyon Dam. It's by near the Grand Canyon. But they produce everything in feet per second. So if you want to look at put the year going from feet per second to meters. First thing is let's get a conversion here from feet to meters. Now format this little conversion program. I think you think to the right of the found on the internet. I don't know what happened. Got it on a website. We had a couple of files again. So this is 14. Okay. And let's point 3 2004 meters in a foot, but then let's also look at volume. I don't think I like cubic feet to cubic meters. Select data, and I think we can switch out column we can put here, and we switch it to a line chart and see just how much more. So and then finally, let's put gravity in constant months. Then that's in these about 9.8. I think it's 9.78 or something like that. Now, if we compute this, why don't we put the release on the head here in meters per second? And in meters. And then we can put the power, let's compute it in megawatt hours. And finally, we can put the implied efficiency, which is the amount of power we're getting divided by the actual generation. Rather, it's the generation divided by the power. So let's first just get our release. Okay, and shift control 1, and let's get our head, which is this one, which we didn't have in this particular period. Okay, and one of the things I'm going to do here is when we didn't have the generation, we can compute the implied generation. So we'll put in assumed efficiency. Okay, and so our power is the release multiplied by the head multiplied by our gravity divided by 1,000. Okay, and finally, our efficiency is the amount of power we produce divided by this. Of course, we will use the little trick. If you want to check that it's not equal to 0, you just put the J10. You don't have to use an if error, just like this. And now, when we have such a long set of data, we can you can just double click. Okay, and here we go. Okay, and there we have the efficiency. Whoops. Oh, great. Okay, just a minute. Okay, so the implied efficiency, there was no data. This is one of the things we're going to fix in just a minute here. The implied efficiency is, come on. Okay. Just a couple more. I should have used it. Let's do this. Okay. It's 88, 88, 87, 87, 89, and there were a couple with more than 100%. Now, if you want to just compute something fast, so let's start doing a little analysis. We can put the average efficiency and simply, let's put it here. Equal. Okay, I was gonna just select the whole thing, but that's not so hard. Oops. I had to switch it to the if error. Then let's put the input efficiency. Let's just call that copy and paste that. Okay, and shift control F5. So now let's computed generation. And that's simply the efficiency that we input multiplied by our famous gravity multiplied by the head. And we're going to have to put a similar thing for. Okay, I should have, when I'm doing this, I should have wrote down hydropower equation. It's Kw equals 9.8, which is the gravity constant, times the flow in meters per second, times the head in meters. Okay, that's what and finally times the efficiency. So this computed generation, now the data didn't have any generation in the first few years, so now we have some computed generation. And why don't we let's make our first graph. So let's start with the data analysis and compare our computer generation to the reported generation. Okay, and that would be so let's put the generation here. Now, whenever you make a graph, rule number one, let's start with the graph, is the x-axis. Don't put shift control 3. My date's in French. Don't put a title above the x scale, and then it'll know which ones to that this is supposed to be the x scale. Okay, that's the big rule with F11, or for that matter, inserting any kind of graph. Shift F9. Okay, so now let's just go here and then press F11 to make the graph. Okay, so here's the result of the F11. I had to pause the video. We have some problems here that this reported generation, I think there were more zeros. I think there were some zeros in the data, so we're going to fix that one and then continue. Okay, so that's just a little bit, and let's put applied generation, and let's put if this is greater than 0, then we'll use it. Otherwise, we'll use the Okay. I had to multiply the false by 1. So now we have our final data series. All right, and now let's begin doing some analysis with this. Let's first graph this one. Oh no. Okay, now we're going to try to take a look at this hour by hour data and do some summaries of it. So let's do the easiest one first. So once you have the dates, then the way to summarize this, let's say we want it by year, is just put the year of the date. When this thing comes, you have to press Shift Control and the little approximate sign, so we get the dates for all this. I'm going to have to put the recalculate button on, and then let's do 1996, and then just, and then I reformatted it and just add 1. Okay. I have to, unfortunately, I can't press the F9 button. Okay, and last year we had this one. Okay, so once you have the data formatted like this, you can simply use why don't we use the average if, because the last year is not a full year. So to use the average if, just click on the range first. I think it's so much easier, and this is a key part of this whole exercise, is to just click on the things at the top rather than I must have the recalculate button on rather than click on the entire columns. Things at the top, entire columns. This is a horrible video. And then let's just put annual generation. Okay, again, shade this and F11 to make the graph. So you can see that, well, there was some high years, but there's a really very low amount of volatility, and we had one year that was a little bit higher, and the rest of the years were almost identical production on a year-by-year basis. So we're starting to get some more interesting information. Now why don't we get this on a month-by-month basis? And the thing we'd like to investigate here is, okay, I added some lines. Let's put the monthly. Let's do this on a monthly basis. Now, and I think maybe I'll even at the end we'll do it on a quarterly basis to show you how that works. If you want to do this on a monthly data, the key thing is to use EOMONTH function. And the problem, and this is the issue with quarterly data, the issue with the quarterly data, that there's no EO quarter function like this, and that's such a helpful function. It allows you to do everything, so you have to make your own EO quarter function. For now, that's what I just did is made it with a 0, so it just takes you to the end of each month. All right, and then on the month, so for the monthly one, we can start with the very first one, and then simply put a EO month and go to the last month and increment it by 1. Okay, so here we have January, a whole lot in January, a whole lot in January. Oh, because I didn't recalculate. Okay, and then we'll make February and so forth. So we'll just pull this down, Control D, and then once we've put all this in, and I'm going to recalculate after I pause the video again, we just do another SUMIF, or should we do why don't I do an AVERAGIF? Okay, tab over, click on this time instead of the year, click on the month, see if it's equal to the month, and then click on all the generation again. So that's the same sort of idea. We just have to do it on a monthly basis. Okay, if we want to do the same thing with the end of quarter, here's the function to do this. You can find this function in the generic macros, and what it does is it just reads in a date, and if the month for that date is January, April, or January, April, July, or October, then we take the end of the month. We take a worksheet function for the end of the month and go 2 months forward. If it's other dates starting with February, May, and so forth, then you add 1 date, or if it's the month that's the end of the quarter, which is March or June or September or December, then you just go to the end of the month. So that's how you can make an end of the quarter date. And again, that's in generic macro. And there's another video that shows you all the other functions in this generic macro and how to upload them. So let's go back, and now we can, instead of month, we can put month end here. We can put quarter, and we just put EO. look at this. I just didn't import it. So let's so we need to import it. This time I'm just being lazy and I'm just importing it directly from the notepad, and we can go right into our file. Sorry, I keep making mistakes here. Then we can put EO quarter, just like EO month, and we just put the month in, and hopefully we get the end of the quarter. So we just do exactly the same thing where we get the end of the quarter for each period, and then we'll make our quarterly analysis. And to make a quarterly analysis, again, it's average if, and we click on the quarter range, and then you click on the, oops, we need, okay, really going slowly here. Okay, to make the quarter date, we have to start with the end of the quarter, so I'm going to make it start with 1995. Whoops. And then after that, we'll just use the EO month and go up to the last quarter and add 3. And then we can just drag that down just like we did the months. All right.